Assalamualaikum and hello everyone. So now I'm going to present my final project proposal. This is my name and this is my metric number. And the title of my final project is fabrication of textured silicon. So first I will explain the introduction. Sterilization technique on silicon surface is done to reduce the reflectance of the silicon surface. There are a lot of silicon surface structure that researchers have fabricated, such as pyramidal structure, inverted pyramid structure, V-groove channel structure, conical structure, and nanowire structure. So all these structure has low reflectance compared to flat silicon surface. And there's two types of etching: anisotropic or dry etching, and isotropic or wet etching. So with anisotropic etching, this is silicon or sample. The etching is a straight line, meanwhile the isotropic etching is curved line. And one of the main applications of textured silicon is solar cell. This is because textured silicon has high light absorption that result in high efficiency of solar cell. And then the problem statement. So flat silicon surface has high reflection losses. As we can observe in this figure, when the light hits the flat silicon surface, it reflects back immediately back to the environment, that result in high reflection losses. But with inverted pyramid silicon surface structure, the light reflects between the inverted pyramid silicon slope plane first before it reflects back to the environment, that result in low reflection losses. And the second problem is that fabrication method that involve advanced technology is complicated and expensive. For example, fabrication method involves sputtering method, dispositing metal layer, and laser-induced method is not cost efficient, complicated, and not suitable for mass production of textured silicon. But simple and cost-effective method like the etching process result in uneven pyramidal structure size and inadequate surface morphology like this figure. Thus, we need to improve the wet etching method to get smooth, uniform, and low reflectance inverted pyramid silicon structure like this figure. The objective of my project is to fabricate inverted pyramid silicon structure to determine the optimal concentration of potassium monoxide for silicon etching and to examine the texture, surface morphology, and reflectance of silicon surface after fabrication process. The scope of my research that this study will be done by analyzing the surface morphology and reflectance of the silicon surface with three different concentrations of potassium hydroxide. So basically I will have three results. Potassium hydroxide and isopropyl alcohol are selected as a chain to etch the silicon, and the concentration of potassium hydroxide will vary to 10, 50, 20 percentage, and the result will be three different depths of the inverted pyramid silicon structure. I will compare which of the three samples has the lowest reflectance. Then this is the flowchart of my proposed method. I will explain in detail in this illustration. So my methodology is chemical etching. So this side view and this top view of my sample of silicon. First, silicon will be spin coated positive result in this. And then the exposed result is stripped or developed using potassium hydroxide developer to get this. And then the exposed silicon dioxide is removed using hydrochloric acid. So this is exposed silicon area. And then the exposed silicon surface will be etched using 10, 50, 20 percentage of potassium hydroxide and 250 ml isopropyl alcohol. So I will expect to get this uniform, low reflected, and smooth inverted pyramid silicon surface structure like this figure. And this is the chemical reaction of this process. So this final result of this chemical reaction, silicon dioxide with the ion easily dissolved, and this silicon will get etched, and I expect to get this result. And the significant of my research is that my method is simple and cost effective, and the inverted pyramid silicon structure effectively decrease total reflection and has low reflectance, and my material could be used as material for silicon solar cell to improve the silicon solar cell efficiency in solar cell application. So that's all from me. Thank you.